frog jumps 2 meters, how many centimeters will that be? In this lesson, you will learn about kilometers, meters, centimeters, and millimeters by comparing their sizes. Let's review. Customary measurement is the standard unit of measure in the United States. It's on one side of the ruler. The units are miles, yards, feet, and inches. The metric system is an international system of measurement. This means it is used around the world. The metric system can be found on the other side of the ruler. The units that we will be learning about are kilometers, meters, centimeters, and millimeters. Please notice that centimeters are on the metric side of the ruler. The meter is the main metric unit for distance. Milli means 1,000th. Notice the th on the end. Remember from fractions and decimals that this means it is part of a whole. Just like this millipede, it looks to have 1,000 legs. Each leg is part of the whole millipede. In this lesson, our whole is the meter. A millimeter is 1,000th of a meter. In other words, it takes 1,000 millimeters to make 1 meter. Centi means 100th. Notice the th on the end again tells us it is part of the whole. Think of a penny as a cent. A penny is part of a whole dollar. It takes 100 cents to make 1 whole dollar. The same way it takes 100 centimeters to make 1 whole meter. The centimeters are numbered at the top of this meter. Kilo is a little different as it means 1,000. No th on the end this time. This is because we are no longer talking about part of the meter, we are talking about the whole meter. There are 1,000 whole meters in 1 kilometer. Notice in the chart that all of the words have the root word meter in them. This is because the meter is the main metric unit for distance. Let's use this information to solve a problem. If a frog jumps 2 meters, how many centimeters would that be? We need to first identify which units we will be using. The problem tells us that we will be converting meters to centimeters. Next, we set up our conversion chart using meters and centimeters. The prefix centi tells us that we will be using the number 100. We know there are 100 centimeters in a meter, so on our conversion chart, we write 1 meter equals 100 centimeters. The problem tells us that we keep converting until we get to 2 meters. The answer is 200 centimeters. There is another way to solve this problem. We can multiply 2 meters by 100 centimeters. To solve this, we multiply 2 times 1, which equals 2. Then we put the 2 zeros at the end. Our final answer is 200 centimeters. Either method is correct as we arrive at the same answer. You just converted meters to centimeters. Here we see the frog as it jumps 2 meters or 200 centimeters. Let's solve another problem. A hot air balloon floats 5,000 meters above the ground. How many kilometers would that be? We need to first identify which units we will be using. The problem tells us that we will be converting meters to kilometers. Next, we set up our conversion chart using meters and kilometers. The prefix kilo tells us we will be using the number 1,000. We know that there are 1,000 meters in a kilometer, so on our conversion chart, we write 1,000 meters equals 1 kilometer. The problem tells us we keep converting until we get to 5,000 meters. 2,000 meters equals 2 kilometers, 3,000 meters equals 3 kilometers, 4,000 meters equals 4 kilometers, 5,000 meters equals 5 kilometers. The answer is 5 kilometers. There is another way to solve this problem. We can divide 5,000 meters by 1,000 meters. 5 divided by 1 equals 5. We drop the zeros. Our final answer is 5 kilometers. Either method is correct as we arrive at the same answer. You just converted meters to kilometers. In this lesson, you have learned about kilometers, meters, centimeters, and millimeters by comparing their sizes.